All right, so a podcast. This is another one. This is an impulse equals change in momentum type problem, but they give you the impulse. They give you different looks in terms of the impulse. In the first one, it says on the first impulse, Cassie experiences an average force of upward force of 230 newtons for 0.65 seconds. So I can get the impulse from those two numbers. Then it says the second impulse of 112 newton seconds lasts for 0.41 seconds. Well, that's an impulse right there. And then it says the last impulse involves an average upward force of 116 newtons, which causes an 84 kilogram meter per second momentum change. That's an impulse. So you have to sort of distinguish what's important from what's not important. And for example, in this problem right now, if I'm just looking at the impulse, this number right here is not, it's not going to help me get the impulse. And same thing with the last impulse. It says an average upward force of 116 newtons. That's not going to help me get the impulse. I want the total impulse. So it says, let's start at the beginning here. Cassie has just finished her session on the trampoline during PE. As she prepares to exit the trampoline, her vertical momentum is reduced by a series of 3 resistive impulses with the bounce mat. Just prior to the series of impulses, her 48.5 kilogram body is moving downward at 8.2 meters per second. So you can call the down direction positive or negative, whatever you want, as long as you're consistent with everything here. So if I'll call down, since down is usually negative, I'll just call it negative. Okay, so we know how fast she's going to begin with. So her original velocity, if I write this down, her original velocity is negative 8.20 meters per second. Then she experiences 3 impulses, and the question is, what vertical velocity does she have after these 3 impulses? So if I can get the change in velocity, and I know her mass, then I can get her final velocity, because her change in velocity is going to equal her final velocity minus her original. So we're ultimately going to be solving for her final velocity. So her final velocity is going to equal her original velocity plus her change in velocity. So what I want to get now is her change in velocity. Now the main formula that we have is that impulse equals change in momentum. And there's 3 impulses. Now the impulses are going to be, let's figure out that first. So the impulses are going to be, if I look at the problem, on the first impulse, Cassie experiences an average upward force of 230 newtons for 0.65 seconds. So that's the force of impact, that's the time of impact. So to get the total impulse from that, I just multiply those 2 numbers together. Because remember, this also equals Ft, like J equals Ft. So if I know the force and the time, or if I know the mass and the change in velocity, either way I have an impulse. So in this case, it's going to be 230 newtons, and since it's upward, I'm going to call it positive. So it's a positive 230 newtons times 0.65 seconds. So that's the impulse from the first one. Then the second impulse of 112 newton seconds lasts for 0.41 seconds. Well, if I was solving for the force during the second impulse, I would need the 0.41 seconds. But I don't need it if I'm just adding up all my impulses. So that number is my second impulse. So I'm going to add in 112 newton seconds. And notice again, it's newton seconds. It's not newton divided by seconds. It's newtons multiplied by seconds. And then the third is, the last impulse involves an average upward force of 116 newtons, which causes a 84 kilogram meter per second momentum change. Well, if that's the momentum change, that's the impulse. Impulse equals change in momentum. So that's going to be 84 kilogram meters per second. Now, if you look at this, I get Newton seconds here, and I get Newton seconds here. Well, that right here, this number, is the same thing as Newton seconds. So I'm just going to add those three up, and that's going to give me my total impulse. If you add them up, what do you get? What is it? 246. So 246 Newton seconds. Well, impulse equals change in momentum. And I guess another thing I could write here in my list of things that are all equal is M. It's 346? Okay, so 346. So all of these things here are equal. Impulse equals force of impact times time of impact. Change in momentum equals mass times change in velocity. Impulse equals change in momentum. So all of these things are equal. So whatever helps me figure out this answer, that's what I'm going to solve for. So I know that, and I know her mass. She's 48.5 kilograms. So if I know the mass and I know that, I can solve for the change in velocity. So I'm going to do that. So my next step is my change in velocity is going to be the impulse divided by the mass. So I'm going to put 346 Newton seconds divided by 48.5 kilograms. Now, the answer that I'm going to get here is going to be positive because the change in velocity is a positive number. So if I solve that, what's 346 divided by 48.5? 7.13 meters per second. And over here, I already said what I need to do to get the final velocity. I now have the change in velocity, and I have the original velocity. So just put those together, and that's going to give me my final velocity. So let me bring this up a little bit. So my final velocity, I'll do it right here, is going to equal my original velocity plus my change in velocity. So my original velocity was negative 8.20 meters per second, and my change in velocity is positive 7.13 meters per second. So if I add those together, it's going to be a negative number, or negative 1.07. Would be the velocity. So even after bouncing on the trampoline, the person's still going to have a down velocity after these three impulses. Is that what I gave you? Okay, now I have negative 1.08, so something was rounded a little bit differently here, but that's pretty much the answer. Any questions?